even well known for his contributions to the practice as well as the technology of finishing processes. And he has worked, has been a leader in the industry, working with Norton, and later I think it became Saint-Gobain. And he has mentored a lot of people, both in the industry as well as academia in this front. And in the last 10 years, I have known him as a collaborator with Professor Ramesh Babu, and actually being able to translate some of the research as well as technologies which are at lower technology readiness level into actual practice. And I really enjoyed learning about the intelligent machine tools that he built as part of Micromatics. And one of the reasons why I would like to have him as part of our part of our project meetings is to learn from him about some of his vast experiences, especially in translating, or what it takes to translate some of these technologies, and how we can think about our research so that they are easily translatable to industrial practice and create value.
The system thinking and transformational skills. What is it? Why is it essential for the 21st century professionals? In fact, it was needed even for the second half of the 20th century professionals, which is who I was, and I continue to be now into the 21st century. Now, on the other hand, because of the discussions with Satish, it's a very useful one. Instead of keeping the seminar just by itself, I divided into two parts. The first is to give you a quick overview of this topic, and then go on to give you how it is applied in a real-life example. And with that, we will then at the end have some discussions. And anytime you have comments or questions, put them in the chat box or wherever, and we can come back and pick it up as we go forward. So to ask the question, to start the seminar, if I were to ask the question 2 + 2, obviously you will know the answer very quickly. And in fact, those of you who know the answer, write it down. We'll come back and check your answer a little bit later on. And of course, some of you may be thinking, what is this doctor? By the way, Satish, I am Dr. Subramanian. Professor is a title you gave me. I appreciate the honor. I tend to be academic, even though I come from industry. Nonetheless, so you may think, Dr. Subba, what is this no-brainer question you are starting us with? Well, let's go to the next no-brainer question. How is the work? Organizationally, people know that there are blue-collar jobs, then there are white-collar and middle management, and then senior management. What is important in this picture is pyramid is that those who are in the blue collar could rise up to higher level, and they could pick up the knowledge of the white collar work, and then they go to middle management. From there, they can move on to senior management. As you know, the CEO of Exxon, who was in the Trump administration, actually started as a blue collar worker, and then he rose to the ranks to become the CEO of one of the largest companies in the world. As a result, the wealth of the people was not only accumulated at the top. In fact, when I started my career, when I went to work at Ford Motor Company, the worker in the factory floor who will work 12 hours a day and 7 days a week would get double overtime. As a result, he will have one house in Michigan, one house in Florida, a big boat or yacht in Florida, and a trailer to take it from Michigan to Florida every summer. And he'll work only 9 months a year, and 3 months he will take off for having a good time. I don't think any of you would have the luxury to do it today. Even your dean or your chancellor would not have the luxury to do that today. Why is that? We'll talk about it in the next slide. So the work, as we know of it, is kind of getting divided into 4 distinct categories. And they're impermeable layers, sadly enough. Blue-collar work or physical labor. We no longer call it blue-collar work. It's actually physical labor. Or information work, which is where you write the codes for programs. And then professional work. And then investment and finance. Now, sadly enough, these are impermeable. And only a small segment of this work, which we call professional work, is where really the opportunities are. And that is why a lot of people are told, You have to be entrepreneur. You have to jump from job to job. You have to work harder. You have to work smarter. You have to be an expert in engineering as well as history. And all kinds of expectations which are so enormous that one wonders how we can be possibly do that. On the other hand, this also gets divided between non-wage income and wage income. So most of us who are professionals and information workers and physical labor earn our living through wage, whereas the non-wage income is the other portion. And if you look at the wealth, as a result of which, top 10% own 85% of the wealth, and then the middle 40% own only 14% of the wealth, and the bottom 50% own approximately 1% of the wealth. You may be wondering why Dr. Subbu is talking about all these details about global economics and jobs and careers and things like that. Because all of these things affect us, each one of us personally. So let me ask you my second question here. Instead of 2 plus 2 equals what, for which you would have written down your answer. How many of you think you're scientists? Write down a check mark in your notebook. How many of you think you're engineers? Write down in your notebook. And how many of you think you're managers? Write down in your notebook. We'll go further and come back and check on that. So 2 plus 2 equals 4. Okay, no brainer. At least I've given you the answer as most of you might have written down. But I would like to ask you the question, is it really? Then the second question is, how many of you asked a question or wrote down, what does the 2 stand for? If any of you wrote down, that will be great. Enter your name or however in the chat box. So we'll come back and check that. Now I tell you, the 2 plus 2 I had in mind was an orange and apple on one side, banana and pineapple on the other side. What does this 2 plus 2 stand for? Well, you may say it's 4 varieties of fruits, in which case your arithmetic is good, but your system thinking is not evolved yet. Then I like to give you, what is it that we as professionals do? Why is it important? Because large fraction of the professionals end up being the only ones who really have the true knowledge of the products and process of the company. So the output of every professional is a product or a solution of value to the user. That product, when it's used, the customer gets a value out of this, and that generates the revenue. Most people think the product generates the revenue, which is a fallacy. Product, you can have all kinds of products in your warehouse, in your stock inventory, but that by itself does not generate revenue unless it is used by the customer to generate the customer perceived value. And it's the customer perceived value that also determines what are the needs that are satisfied and what are the needs that are not satisfied, as a result of which you identify new opportunities through which you do new processes leading to new product and then the use. So as you can already see, there is on the input side from professionals output, which is the process, product, and use, and that gets transformed into customer perceived value, and the output then leads to revenue and customer needs satisfied or not satisfied. So you're beginning to get the sense of system thinking even at this level. So as such, every one of you, whether you're a student, whether it's a professor, whether you're a postdoc or a researcher or any engineer, it doesn't matter. Your outputs are process, product, and use, and they're interrelated. If someone says, I'm working on manufacturing process research, means absolutely nothing unless that process is connected to some product and that product is connected to use by someone. So any change in any one of them is an opportunity for change in the other, and hence innovation is not something that is serendipitous, but it can be very predictive and deterministic. So in fact, a whole new field is emerging in the West Coast called customer success management, only for the software industry. But the same customer success management in the hardware industry is what I did for 2 decades ago, and implemented a whole series of application technology centers, which are working successfully now, even now worldwide. And every one of you have an opportunity to create a customer success management team and applications opportunity, And if you're at the university, dean level or some level of authority, you can bring the faculty together and create customer success management for industries in your own area. We can talk more about it later on how to do that. But the point of this slide is product, process, and use are the three outputs of any professional. They are interrelated, and each of them can be treated as system. And together they create a system of input, transformation, output. And the output is a customer perceived value which generates rewards. And the not satisfied needs of the customer create opportunities for process. And hence, innovation itself can be deterministic and not serendipitous. Now, let's look a little bit more about what is a system. Now, there are different definitions of system, and I also know you have your own course on system and so forth. But let me give you a definition here. Every system is an input, transformation, output, scheme, or arrangement. The output itself can be divided between what is it you're trying to produce and why you're interested. In the problem 2 plus 2 equals what, I gave you input side, orange and apple, banana and pineapple. But I did not give you the what on the output side. Nor did I tell you why I'm asking the question. So unless you are satisfied with those, you cannot go into executing the system. And also you need to know how to get at it from the bunch of pineapples sitting in 4 different baskets. And the transformation very often is a black box. And you think you are teaching the transformation through quote unquote science, but unfortunately, that never becomes part of the system as soon as you leave the university. So how do you make this transformation become an integral part of every job we do, either at the university or any job or any career, or it's really a challenge we face? We can arrive at that by looking at what is called the value addition score. What is a value addition score? The knowledge and its use is that's what a professional does. We also do information work. We also do physical work. For example, when in this seminar, we have you are all input side as students or audience. I am on the input side as a teacher or faculty or providing the seminar. All the slides, all the material, they're all part of the input. The transformation is the attempt to share the knowledge from what I have to what you need. And then what you get out of it and why you will benefit out of it will be the output. So we already described this seminar as an input transformation output scheme. So similarly, any project, any activity, you can take it and divide it between any course you take, you can describe it in this context. So in that, there are only 3 things involved: the knowledge and its transfer, which is used, A, information work, all the slides I prepared and the projector we are using, the computer network, all those things, and the physical work, my talking, your listening, sitting down, all those things, information work. So the value addition score is knowledge work or use of the knowledge divided by the effort put into knowledge, information work, and physical work. So that score is what we call as the value addition score. So one thing in system thinking is always calculate the value addition score. If you cannot calculate the value addition score, then you're not engaging in a system, you're only engaging in a task. For example, you ask me to give a seminar, I give a seminar, we go away, there is no knowledge transfer, we did a lot of physical work, but we cannot actually quantify any of these things, then that's a task. When we quantify and arrive at it, at least we're thinking about a system. When you maximize the value addition score, then we have got a very optimal system or ideal system or a system with a great degree of impact. Why is it necessary? Because if you take an equation with a numerator and a denominator, you see my math is very simple. It is not as complicated as some of the equations you may be writing, for which I take my hats off, because I'm never good at those kinds of things that you do. Nonetheless, you've got a numerator, you can increase that. That is one way to increase the value addition score. The other way is to decrease the denominator. Obviously, with a certain knowledge content, you want to do that, so you don't change the A, but you can decrease the effort put into information or labor. And everything we do using digital technology is attempt to decrease B and C. So that you've got two modes of improvement value addition score. One is creating new solutions by higher value addition through the knowledge. The other is to replicate what's already known through high volume plug and play solutions by decreasing the effort or put into through information work and physical work. For example, once you have recorded this seminar, all you can disseminate it to 100 people, 1,000 people, 10,000 people. It doesn't matter. So you'll be creating the application solution on the right-hand side. But on the other hand, this seminar by itself will be hopefully the left-hand side for a new solution. So system thinking then requires constantly thinking about new solution versus application solution. Why is it also important? There's a big crisis in the middle. If you only think what you did that was done yesterday and continue to do it and more people can do what you're doing today, then you can be sure you'll be pushed into the right-hand side. If on the other hand, you're creating out of what you did today something new by adding a little bit more to your numerator and also taking advantage of B and C, no arguments on that, but your weightage is on the A, then you're moving towards higher solution. That in truth is the innovation, entrepreneurship, moving from job to job, creating, adding value, being interdisciplinary. All the things that they talked about in all the words can be taken into this one picture. The wrap up then we said, we have product, process, and users are output of any professional, and it has to result in user perceived value, which results in revenue, reward, profit, whatever you're looking for. It also identifies satisfied needs, and those that are not satisfied creates opportunity for new process, and cycle continues. This can be for a physical process, like a manufacturing, a product, things like that. It can also for education process, any process you think about. Then there is a gap. We have to constantly keep jumping from replicate, plug and play solutions to new solutions. And then don't sit there forever, but move back into replication. Because there are a lot of people who think that they can innovate and stay there. You cannot. What happens to most entrepreneurs is they jump from right-hand side to left-hand side. Then somebody else buys it and it becomes, or you make an IPO. And then they move to the right-hand side. Then once they are on that side, 2 or 3 years later, they jump back to the left-hand side. So this is the cyclicity that an innovator constantly pursues. And those who move to the right-hand side usually get lower paying, low reward jobs. Those who move to the left-hand side are the new solutions, usually is a high paying, high reward jobs, because that's where the knowledge gets used. That is why we call our economy 21st century economy as the quote unquote knowledge economy. It is not because IT and computers are doing something like artificial intelligence and robotics, but the value of the knowledge when it's packaged into new solutions is much larger today than it ever was. And the opportunity to take it into the market and the customer space is much larger today than it ever was. So, and you can then see the people on the right-hand side are usually 50% of the population with only 1% of the revenue or 1% of the wealth. In the new solutions, most professionals, 40% with 14% of the wealth. And then the non-wage income is where 10% of the people with 85% of the wealth. Or somewhere in between, you can kind of make a little bit argument for that. So coming back to our simple question, 2 plus 2, if you think it's a no-brainer, then if you understood that 2 plus 2 implies orange and an apple, banana and pineapple, then you cannot simply tell me 2 plus 2 is 4 variety of fruits, because that is purely arithmetic, but that's only task-oriented. But if you ask me, why did you ask this question? What is it you expect out of this? Then you have to begin to act as a system thinker. Essentially, you can think of any system involving a machine, tooling, work, parameters as the inputs, and the transformation, which is the science of the process, which you can measure and analyze using diagnostic tools, what you're interested in, why you want to do that. So it's the what and the why determine the strategic aspect of the management and how to make it happen with respect to the science in an efficient economic manner, the operational aspect of the management. Bringing all the inputs together to exploit this transformation is engineering behind the process. the transformation itself, which is applicable irrespective of wherever the transformation takes place, would be the science behind the process. Then you will say technology is science times engineering times management, which involves operation plus strategy. In other words, technology involves science, engineering, and management. If any one of them is zero, technology is zero. I had to share this with you because when you go to, if you fortunately if you have $50,000 and you want to invest in stock market today, and you give it to a broker and say invest in the technology sector, he's not going to invest in Pratt & Whitney or General Motors or Chrysler or whatever company you have in mind, because they're not part of the tech sector. What is in the tech sector is IBM, Google, Apple, Twitter, Facebook. Why? Because the very notion of technology has been hijacked to think that technology means digital technology and not a science-based solution. Why did that happen? Because those of us who work in that field have let that happen. Because I asked you earlier on, how many of you are scientists? Probably very few would have said yes. Many of you would have said you're engineers. How many of you would have said management? Probably nobody. So do not think that only a guy who is wearing a white coat is a scientist, a blue jacket is an engineer, and a pinstripe suit is a manager. No. Every one of us is a system thinking, is a scientist, an engineer, and a manager. If any one of them is zero in our thinking, the value of our technology is zero, as seen by us, and as seen by the users, and as seen by the society. So when we say that we do a PhD in mechanical engineering, but nobody wants it anymore, things like that, because we have devalued it ourselves. It's not that somebody else devalued it. So valuation and devaluation is within our own hands, within our own capacity. So that brings us to three levels of system thinking. I will not belabor on this. The first is awareness, where you can fill all the boxes. I have put two schematics here. One is for pertaining to a machine or an industrial process. In other one, which involve machine, tooling, work component, technical, which is a physical transformation, and then output. And the other one is for general investment, expenses, need and constraints, but otherwise the framework is the same. The science, engineering, and management strategy is the same. So to be able to fill these boxes is what we call as awareness. And then understanding what the science behind them is would be, and engineering and management and how to apply them will be called analysis. As a result of which, configure new solutions based on knowledge and its refinement through awareness and analysis will be synthesis. Develop them into new solutions, implement, validate, and get rewarded will be. So again, system thinker now has got three levels of thinking, awareness. So we said 2 + 2 = what? No brainer, 4, okay. But I told you it's 4 types of fruits. But I have to tell you what is the technical output and what is the system, why is the system output. So now if I showed you 2 + 2, in my thinking was all these different things. Now you are telling me, aha, 2 + 2 is a fruit salad or a fruit plate or a decorative arrangement. That's the technical output. And new solutions and getting rewarded for that is my system output. So you see the very simple question 2 + 2 thought of as a system leads to an understanding of what are the inputs involved in the 4 categories. What is the transformation that I had in mind, which is not shown here at all? The result of which is a technical output, and the benefit out of is a system output. This is the simple most thing that is required, and this is our knowledge. No amount of computer can be taught to do that, but every one of us can keep this in our mind everywhere we go. And then use the computers and systems to exploit that, just like this slide is prepared using the computers. So the case studies, there are several of them I have listed here, and I could list another 4 or 5 more out of my career. But let me just pick one of them, grinding of thin film heads for magnetic recording applications, data storage, or computer industry, for new business development. So you may wonder, how is this guy coming from the grinding background, which is usually seen in the automotive, aerospace, or bearings, or at best, making hypodermic needles or something like that. What's he doing in the computer industry? The point here is science, once you understand it, has got ability to permeate any number of applications across the globe. And that is where innovation and opportunities come for those with a scientific background. So the example I'm going to show you here is one where I told you that we started essentially with understanding the grinding of ceramics. We didn't not even have an idea of where we will use it. But once we have perfected the understanding of the grinding of ceramics, which took us about 3 years, then we had to find out where the use is. And we found out there was some use for magnetic thin film head manufacturing. And then the product is what we came up with, which you'll see. In order to make the product, there are so many things in the process that had to be modified. But once the product is modified, let me move it here. Once the product is modified, the process, it had to be used. Through use, we found out some needs, and this interactive story is what I'm going to tell you now. Okay, so system thinking is then engagement in all parts of the system, simultaneous impact in all 3 dimensions, the input, output, product, process, and use, and also having a simultaneous impact on science, engineering, and management. Now, do not think when I say this, it's so complicated. How can I do all these things? You see, the power of our brain is so good that you can do all of these things in parallel, as long as we let our mind be free to do what we want to do, as opposed to be constrained by what we are told we should do. What is the science of grinding? In fact, this model for science of grinding can be used for any number of applications. First of all, if you think of any abrasive application, you've got an abrasive producing a chip, and then abrasive, if it's not producing chip, it is plowing or displacing the material, or sliding on the work material, or the chip that is sliding on the bond material, chip sliding on the work material, or the bond itself sliding on the work material. So it doesn't matter what abrasive application you can think of, these are the 6 interactions that are taking place all the time. So when you got 6 interactions, you've got a normal force and a tangential force, so you've got 12 vectors. So every grinding application comes down to managing the grain work, bond work tribology, machining cycle, grain work, bond work tribology as a function of time, chip bond, chip work tribology as a function of time. So that the 1 vector is here, 2nd is here, 3rd, 4th, 5th, and 6th. And within the 3rd vector, which is a machining, you design a grinding cycle where you have a very high force in roughing, semi-finish, finish, and so forth. And when you come to spark out, you're having only grain work tribology. So in which of these 6 interactions or 12 vectors you are interested? Why? Are these time dependent? For how long? Can they be constrained to be within some limits? How and why? It's always a case. Can they be time independent? For how long and why? So this is essentially the phenomenological understanding of grinding, irrespective of any application. So I can walk into any application, look at the process, divide it into these 6 interactions based on the measurements we make, and based on the discussion we had on the input side, based on the discussions we had on the technical output side and the system output side, we arrive at these criteria, which of these 6 interactions of interest to why, and that essentially is the science of grinding. So essentially, 6 microscopic interactions, their magnitude and relative impact can be used as dominant mechanisms in the design and management of any grinding process. So I have finished teaching you science of grinding in 2 minutes. Okay, now let's go to science of abrasive ceramic materials. In the grinding of ceramic materials, it's the same interactions have to take place, but only difference is the grain work interaction can be cutting, will lead to brittle fracture or ductile deformation. There is hardly any plowing, or there will be a lot of sliding. And this is from the literature. The whole thing, you can get it from the reference for this. Essentially what they say is, when the radius of the indenture is large and the applied force is large, it doesn't matter what you do, you'll always have cracks in ceramics. When the radius of the indenter is small, even then when the applied force is large, you will have brittle cracks in a different kind compared to, you will also have a median crack in addition to lateral cracks. Whereas if a ductile material, whatever the radius you use, whatever the force you use, will always be deformation. But there is a sweet spot in ceramic materials where the radius of the indenter is small, the force applied is small, you end up with having ductile deformation. Now, the reasons for the will vary from the material, its fracture toughness, so on and so forth. But essentially, you're trying to operate in this regime. And if you operate only in this regime, it will be called ductile regime grinding. But on the other hand, you can always be sure, because of this interaction, there will be some interactions taking place in this direction towards brittle fracture, some taking place towards ductile deformation. But it depends upon the chip thickness, which is the volume of indentation. It depends on the force per grain. It depends upon the abrasive particle size, which influences both of them. So essentially, the more you skirt towards the left-hand side, you have ductile deformation. The more you move to the right-hand side, you've got brittle fracture. So in addition to general issues of grinding that you normally deal with, you have to manage this balance. Essentially, that's what makes a difference between ceramic grinding versus grinding of ductile materials. Okay, now we have understood the science, but you have to translate that into application. That's what engineering is all about. So that same picture I showed you now becomes translated into how is it affected as per machine tool properties, processing tool properties, work material properties, operational parameters during the process and output. It'll take me some time, so I would not go into the details, but you can go to another time. So essentially, you're trying to stay mostly on the left-hand side and never go into the right-hand side. But because you can live with some degree of brittle fracture, as long as it's not substantial. And you can live with some brittle fracture and roughing, but you can get rid of it in the finish grinding, just like you will remove the surface roughness, which will be very coarse and rough grinding in ductile materials, and reduce that in finish grinding. Except here, you're not trying to manage the surface finish, you're trying to manage the micro cracks. And essentially, but typically, most of the literature had said ductile regime grinding operating only in this regime, but that is not economical and practically feasible. So what we took was, we took the what is available in the literature, we came up with this model, we understood that we had to stay in a certain regime. Within that regime, you can design a roughing grinding cycle and a finish grinding cycle for economics and productivity and so forth. And you could indeed achieve very high surface quality and low brittle fracture and cracks. Now, all the other principles of tribology apply. So you have to be a very good tribologist as much as a machine technologist if you want to be a good grinding person. So in fact, I would argue that grinding is machining plus tribology. Then machining is a subset of grinding, as opposed to people thinking of grinding as a subset of machining. As a scientist, I'm not here to make politics or arguments or anything like that. But that is what science allows you to think differently from others. Now, you can okay, once you're, then you go crazy, because scientist is also supposed to demonstrate his capabilities in areas that did not exist before. Here is A1 and A2 are two surfaces, both on the same material, except when thermal issues are not managed, it's not brittle fracture. When thermal issues are not managed, you'll end up with A1. When thermal issues are managed, you get very good surface A2. Also, you can grind very mirror-like surfaces in a cylindrical surface or a flat surface. You can take a hollow tube and grind it into a worm and create a spring out of it, and then collapse it like a metal spring. If a metal spring, you bounce it, you can bounce it forever, it may not break. Ceramic spring also, by the way, I have bounced it with great degree of confidence, except you bounce it 10 or 20 times, it will break eventually. But you can make ceramic springs and collapse them just like metal spring. You can grind ceramics to very thin diameter, as shown in E, without any end support. And you can, because the force per grain, the kinetic conditions are so good that you can manage that. And because material has its own inherent strength. You can grind a silicon wafer, which is like a brittle material, and bend it into a plastic sheet of steel. You can grind a sapphire so plain and so good in surface quality that it becomes transparent. So all this research becomes useless unless there is somebody to listen to. So I took this work. I visited many companies who had a need. And just lo and behold, this is where serendipity comes. IBM, San Jose, this is where I'm living now. I made this presentation. A gentleman by name Dick Satterfield, he told me that they have a need to make thin film heads for the disk drive industry. Thin film heads are these on the tip of the arm here, which looks like this. And that is what puts the information into the disk and takes information out of the disk through inductive coils. And he said, we have to make this. But to do that, we have to make very thin slices. I don't know if you can see the slices here. This is ceramic that has been cut into those thin slices. So this is what we have to make. If you're capable of doing that, today we are doing it ferrite, which is a very soft material. We can do it with a resin bonded wheel. But this ceramic, with aluminum titanium carbide, we cannot cut it. It has got a glass in it, electric circuit in it. If you got a grinding wheel, because it's also ceramic, that will do the job, come and see me. So we came back, we made this kind of a sample, as you see in etch, and took it to them. So essentially, I've done the science, I've done the engineering. Now you have to go into the application of the engineering for an intended use that's not fulfilled. But you also have to make choices. It has to be an emerging market. It also requires system integration. Our common word system comes in. So this for thin film head development for this hard storage industry. So essentially what you see here is the thin film head. Now, again, there were so many steps involved in this process, but let me just stay with only the slicing portion of it. So essentially, we ended up with a grinding wheel. It's a metal bonded grinding wheel, with a thickness of 40 microns to 200 microns. These are made of powder metal composites. So they are processed for gang slicing. And this is the set here. And we did all of those things, and we had to do many things. But before that, we had to do process innovation. I can tell you so many things we had to do. We'll come to it in a minute. Essentially, in order to make this grinding process, we had to come up with a metal bond technology. And then the wheels had to be made in very large quantities. The process had to be developed for that. But when you make it, these have to be flat and parallel within micron thickness. Normally, grinding wheels are not made to that thickness, for which you have to develop a lapping process. So when you finish the lapping, we had to get a machine which was $200,000 for lapping. That division had only $1 million for the total capital spending. So here I'm a new guy in the company, and I'm telling my boss, I need a machine for $200,000. So I had to take the technician who worked on the factory floor, by name George Staten, along with me to see the vice president, to say, sir, I don't believe me, but this is the man who has been with you for 25 years. He says he can make it work. And he says, with this machine, we can get a great new business. So he's not trusting me, he's trusting George Staten, who doesn't have an education, but who has got experience and trust in the company. So essentially, there is what we call emotional intelligence, I talk about later on, is part of what has to be part of the innovation. So we buy the machine, we put it in place, and then we had an R&D engineer who would not sleep unless any new specification, he has to make it tomorrow. If not, he won't go home, he won't sleep. And that was his passion. And he had a technician who will make tooling for whatever Dr. Paul Goldman wanted. This guy will make it, or Corcoran will make it, no questions asked. So we have built up a team slowly who are passionate about creating a solution. Yes, we are all looking for a job or looking for a product, but that was not the driving force. The driving force was a solution. So we had to do manufacturing. But even with that, the wheels themselves had to be made for different thicknesses. So we had to come up with a process for that. We had to have work holders, cooler coupling, so many things. Each one of them, we even had to come up with a pricing strategy, because again, this is very closely interacting with the customer back and forth. Because Dick Satterfield tells me that After it's successful, I will need it in thousands of units. But before it's successful, I'll need hundreds of units. But when I'm testing it, I'll only need tens of units. So I'll have to find a way to meet those variety of needs and price it accordingly. And only I can do the pricing because I know the technical side, I know the engineering side. But if I give it the pricing to a traditional pricing department, they can't handle it. In fact, today, most of our supply chain solutions, if you try to make any variation, you will kick it out as non-standard. So most of the things we do as industrial research will be non-standard. So this is where most of the things that most people who do research in industry today suffer and fail because they cannot go beyond the comfort zone of engineering and into the pricing, into supply chain. All of those things are required in order for the solution to be completed. So after doing all of those things, we still were not successful because once you're doing slicing, everything was being made, productivity, everything was good, except the wafers were not plain and parallel. What do you do then? Then you find out that this horizontal spindle surface grinder we're using with a heavy spindle on it was deflecting. We had to cancel as a cantilever beam. So we had to think of a way of solving the problem by coming up with an outboard support, like you do in a twin grip in a centerless grinding machine. So that resulted in a whole new invention of a new machine. Startup of a whole new company to make this kind of machines called MTI. So in the late 80s or early 90s, when everybody said machine tool industry is dying, this machine tool company came out of the ground, and that now essentially ended up with a solution where you have got a new machine tool with a new design, precision. Now we are coming back to the system description of our solution with more details in it. So you see new machine tool, the new design. Also it has to have precision because step and speed capabilities, manufacturing and distribution, custom testing, qualification support. Many of these things most machine tool companies would not offer it because they only want to make the machine and sell it. Customize the wheel fabrication for different thicknesses and spacing, gang assembly. They also have to have distribution services because IBM San Jose may want something, and then IBM Mainz in Germany may want something else, on and on. But once we open our mind, we can learn all these things and accommodate all these changes. Anyway, custom wheel fabrication, gang assembly, distribution service. On the grinding wheel side, we had to come with a new design, new composition, new process, new finishing solution, pricing strategy, people, team. I told you all those things. On the component side, materials technology, they kept changing as they came closer and closer to commercial. Dedicated pull customer. That is the biggest thing. If you got a pull customer who is part of your team, wants to make it work, there's nothing better than that. Like rapid growth market and many startups. And this is what you have to pick ahead of time. Just because you did research and whoever wants it, you just keep trying it. And there are lots of people who want to try because they're task oriented. You have to be system oriented and find the right partner who really wants to make a difference. And many startups were at that time. And then operational factors, so many things, work support, fixtures, process parameters, all those. When you put them all together, remember the seed for all this innovation is the science of grinding ceramics. No question about it. But once the process is developed, if you go and ask how many people can explain the science of grinding ceramic like I explained it to you today, probably a handful. Because seed is like that. It is only when it grows into a tree, which is engineering. Science is the seed, engineering is the growth of the tree, and then management is the maintaining the tree and harvesting the fruits. Sure, if we can let somebody else do the harvesting, somebody else grow the trees, and you be the seed and be complaining that you're not getting attention, or you manifest yourself as a seed, as a tree, and as a harvester, that power is well within each one of you. And the industry or the society is looking for those few, and for them, the growth and opportunities is limitless. So we ended up with a high technical output was a thin film head, and the system output was a high margin growth opportunity for a stagnant industry because abrasives is not a growth industry. But we took a very comfortable, stagnant industry, traditional 125-year-old brick and mortar company into a highly vibrant growth industry, high-tech industry. Of course, there are challenges. In this industry, the cycles are very fast. Today, there are thin film heads made, and because most of your storage for all your cloud computing, all the storage happens to be in these disk drives, because those solid-state drives, USB drives, they're very expensive. They still cannot manage the data amount that is needed. But it's managed only by two companies, Western Digital and Seagate, and probably Hitachi out of Japan. So there will be changes. So you have to keep up with the change. But that's a different side of the innovation. So to summarize it, I told you about the system thinking, and there are a set of seven transformational skills, of which I talked about the emphasis on science, I talked about knowledge integration, and I talked about end-to-end innovation. But there are others. Each one of them will constitute a seminar by itself. In fact, ideally, a course can be taught on system thinking and transformational skills, about 10 to 12 classes. That will be very valuable and powerful, not only for your students, but also for people who are collaborating with you from the industry, and not only for your department, but across many departments. So to summarize then, yes, we need academic education, which you are all providing very nicely. You also need industry collaboration, because that's where this rubber meets the road. But you also need transformational skills, which is not formally taught today. And without that, we are acting only in activities that are task-oriented, and we don't have the time. You have to change reverse the direction of these arrows of doing what you're asked to do and saying, I don't have time, I don't have anything, I don't have a result, life is frustrating, to a transformational where you must be goal-oriented, where every day you do something must have some technical output and a system output, which lead to system thinking, common language. We only had the beginning of the common language today, emphasis on science, knowledge integration. Then we go to end-to-end innovation, core technology platforms, emotional intelligence of innovation, and ecosystem development. So what I have told you today allows you to think in terms of moving away from task to goal. From there, you need to move into impact, and finally into sustainability. So as a homework assignment, because I'm talking to the university and university faculty and student, I'll leave this slide with you. Take this slide and write your own answers. And if you have questions, you can always come back to me. Develop a dictionary for the following words or the meaning. Thank you very much. And if you have questions, we can take it from here.
Again, thank you, Dr. Subbu. You talked about, the curve that you said, like you could stay in the right or you can actually move up in the left, right? The question I have is, we can actually think that, yeah, I want to constantly innovate. What should be the kinds of thought processes I have to bear in mind while I start jumping? I don't want to jump on the wrong thing, right? How do you pick the right opportunity? And then how do you think about, changing directions or changing courses or picking the right kind of a problem or a challenge to deal with?
Very good question. Actually, we are not talking about jumping the right side, right or the wrong thing. We are only talking about jumping from the way we do, the way we should do. For example, whatever you are doing today, take, for example, manufacturing process course you take. I want to move from teaching it like everybody teaches it, more and more of it. That will be moving to the right-hand side. I want to teach it differently in a way to have a greater impact. Create it in a way that adds more value to me, to my students. That will be moving to the left, to creating new solutions. You are doing your own research R&D project today. Every one of you, ask what is the technical output you are trying to do. If a student says, I want to write a thesis, everybody writes a thesis. What's so great about you? So what is it you want to do at the thesis, technical output? Then who cares about it? What is the value out of this? And that very question of what is it you want and why you want that begins to make you think about the science behind your project much more deeply than otherwise. That begins to make you think deeply about what are the various input groups. If you're trying to do a certain experiment without a certain equipment that is needed to carry out that equipment science, you're not going to make much progress. You can do whatever you want. Or if your operating conditions are using that equipment is outside of the ballpark that's needed, you're not going to get the kind of output that you're looking for. The data is going to be just what you generated without making any sense for your output that you're looking for. Or the sample specimen that you want to use for is just because I got this sample, I got this machine, I got these parameters, I generated this data. Who cares? So you see, it is not a question of jumping into something by mistake. It is doing whatever we are doing today, rearranging it and reconfiguring it in a way, making very clear what is it I want to do and why I want to do it. So it's more a question of self-awareness and discipline rather than simply being afraid of taking on something new. Don't do anything new. As a result of this seminar, don't start any new project. Take the project you already have. Take the work you already have. Take the assignment you already have. Redefine it. That is awareness. Then improve on the science, engineering, and management behind that project. That will be analysis. That will lead you to synthesis and new solution. Maybe it sounds a little abstract, but it's almost like telling you can be an Olympic champion. That sounds very abstract. But if I tell you to practice like this way every day, at least you'll become a state champion. Then you'll become a regional champion, and then the national champion, and then you'll be an Olympic champion. Then it becomes palatable. Think like that.
Following up with Dr. Subbu's point, even thinking about a PhD, many times we find that when we ask PhD students, why are you doing whatever PhD? The answer is because my advisor told me.
Exactly.
Right. So, in fact, that is always the bane. I mean, whenever I'm in a PhD defense, I'm always asking why. And what students want to do is talk about how.
Yes.
That is the point that you are making. That is, they're task-oriented. They're not value-oriented.
Exactly.
Right. So what happens is that most of the time they want to talk about, because they have spent a lot of time with how, because the task is hard.
Mm-hmm.
So they're thinking, okay, I slaved for 3 years and trying to figure out how to process the signal, and then one day I got it, and then finally, and you don't want me to talk about that at all.
Exactly.
So that's one thing. On a bigger picture, and this is where I wanted to ask.
But let me just add a little bit to what you just said. See, that's why when we give a PhD, it is supposed to be Doctor of Philosophy.
Yeah.
And the reason we call it Doctor of Philosophy is because we expect the student to be philosophic in their mindset.
Yes. Judgment.
And not simply coming and telling how I did what I did, but why I did it, and what is the meaning behind that.
There are 6 billion people on this planet, and not all of them are going to be able to do it.
Mm-hmm.
So what will happen, and which we are seeing happening, is that there is revolution in various ways. Even the January 6th, forget about the details, but the underlying cause is anxiety.
Mm-hmm, mm-hmm, mm-hmm.
And we as engineers are actually not paying attention to that. That's also part of the issue, because what we want to do, and I've heard this from everybody, is to say, whatever I am doing, I want to automate.
Mm-hmm.
And you're wondering, okay, then what's going to happen to people? Mm-hmm. So what will they do? If they have nothing to do, if they have nothing to lose, they will burn everything down.
Mm-hmm.
So my question to you is, what do you do with the people whose skills are on the bottom? That is, they can make things, but they're not necessarily innovative thinkers. And that is fine too, but there has to be a way, there has to be a place for them also in this world. Otherwise, the one thing that they know how to do is burn everything down, because they don't care anymore. They're not invested anymore.
I think you asked a very, very good question and a very relevant question. But see, in fact, I can give you a very, I think, reasonable answer to that. And that is, first of all, we have to acknowledge that the world is becoming bimodal. What I call as a binary economy in my book.
Mm-hmm. Mm-hmm.
That is the haves and the have-nots.
Mm-hmm.
What I'm trying to do with this system thinking and transformational skills is to move as much people as we can into the have side of the equation and not fall into the have-not side of the equation. That is, first we have to try to do, because that is required. Because if you're not on the if you're not on the shores, you cannot pull someone else in the water out onto the shores. So, and most of us are in the water trying to be pushed by the stream. So we have to find a way to get to the shore, which is what this seminar was. Now, having said that, I wrote an editorial recently, which I'll happy to send it to all of you.
Yes, please.
Which says, this is an Indian magazine, but it doesn't matter, it applies everywhere. And that is, we have to create a way of thinking, a way of life. See, wealth, economic well-being, social, psychological well-being, and then mental awareness and comfort. Those are three different aspects of human life. So what has happened is today, now we are going to subject completely outside of the mainstream of the theme. So many youngsters may not even care to listen to it, but it's affect them as much as anybody else. So on the economic side, to be competitive, you need system thinking and transformational skills. For the emotional side, you need to have all the social, relationship, friendship, all the things. But on the more intellectual harmony with the mind, you need to be a little bit more philosophic, which is where the traditional philosophies say that is, and education on that has to start. Education has to, so that, see, after you have a car and a house and things like that, you don't need to have two cars and two houses and things like that. So you must develop a mental framework. So that's called maintaining equilibrium in activities and life.
Yes, sir.
Recently, I did a 20-week course on philosophy to a group of students in IIT Madras and engineers around them on this subject, because I wanted them to learn that yes, some of your top students will always go abroad. That is the way things are. You can't do anything about that. But if you can create a climate and culture such that the rest of the students who are there feel a sense of belonging, then they will do a very good job for you, irrespective of how many leaves your institute.
But I agree with you, sir, because I think you have a very, very good point, and that is actually related to something else. Many of the students are actually driven by their parents. And I always tell the students in IIT, first thing, stop listening to your parents. Because what happens is they are saying, oh, it's all fine, but why don't you just go to HSBC and become a what is that, a glorified clerk, as Dr. Kumar called it. So you go there and then you become a glorified clerk. Because it is such a mind and soul numbing job, they have to give you a lot of salary. Otherwise, nobody will do it.
Yeah.
So this has to do with mindset as too, and this is actually related to this whole thing, this systems thinking, which is a production mindset versus a job mindset. What am I producing? There's a value mindset. What value are you producing for the world?
Right.
As opposed to saying, what am I getting from it?
Right.
And I think that from a very fundamental point of view, even when we do research, I'm always reminded whenever I talk to the AI and artificial intelligence people, that they are like the 5 wise men and the tiger. That is our inability, because we have always been taught systems isolation and not holistic thinking. Right? So our first step is to draw a free body diagram, eliminate the surroundings. Right? So what happens is we think that every problem can be made into a small technical problem to which I found the solution. But it creates vastly more difficulties than it solves. A good example is what we are doing with plastics today.
Yeah, but on the other hand, the free body diagram is not by itself bad as long as you know the context.
No, but that is the problem, right? So you go back, and I think that actually it starts maybe even before college. It probably starts at like 8th grade, 9th grade. Those of us who are trying to teach our children to think about core concepts, very quickly they tell us, I don't want to hear this. My teacher has given me an algorithm for which the answer she already knows. I just want you to show me how to use the algorithm to get the answer that they want.
Sure. So for the benefit of today's discussion, Professor Arun, Professor Srinivasa.
Yeah, just call me Arun. That's
what I would like to conclude is by saying that the way the world is the way it is, But let us start a beginning today with
Yes,
all the
I agree
people
with
who are
you.
here,
I agree with you. Yes.
saying that each of us should start with an awareness of a process,
I agree
whatever
with
we are doing in system. Then we'll bump it up to analysis.
Yes, sir.
And then move it towards synthesis.
Yes,
And
I agree with you.
that,
I think that was a very
if
valuable
that becomes
point.
our way of life, then people around us will begin to do that. And eventually, if I were to have a dream in a Texas A&M, few years from now, every undergraduate student will be living with an awareness level of system thinking and analysis. And then every graduate student will be living with an analysis level. And every PhD will be living with the synthesis level of system thinking and transformation. So
And
if you can calibrate yourself, and that will, and you would be really making a big difference without anybody even knowing about it.